my name is Janet.
Hi, my name is Anis.
Why is it so many?
Hi Sophia, what are you doing?
Why me?
Anis.
I searching for a hair care product that suit with me.
Huh? What happened to your hair?
I got hair fall problem.
Oh, I think you can try some hair care products from Herbal extract.
Wow, really?
Yeah.
Why?
Because it can prevent your hair fall, reduce your dandruff, and improve your hair texture.
Wow, that's so interesting.
You guys want to know, in herbal extracts, there are a lot of component mixture. And as science students, we can actually separate them using chromatography.
Wow, can you explain it more?
Though.
You do?
Do you guys want to know more about TLC chromatography? Swipe up!
What is chromatography? Chromatography is a separation technique of components from a mixture, according to how much of each solid is present in flowing fluid stream, which is we call it as a mobile phase, and a stationary phase that is continuous. While the stationary phase can be either a solid or a liquid, the mobile phase can be either a liquid or a gas. There are many types of chromatography. For example, we have column chromatography, ion exchange chromatography, gas chromatography, thin layer chromatography, and so on. So today, our group will present about thin layer chromatography. What is thin layer chromatography? Thin layer chromatography is a type of absorption chromatography. The mobile phase is a liquid which is volatile solvent, and the stationary phase is a solid absorbent. For example, silica gel, alumina, or cellulose. It's coated on a glass plate or a thick aluminum foil or a plastic sheet. In addition, thin layer chromatography is one of the type liner chromatography. So here is a technique of TLC chromatography. A little quantity of the mixture solution to be examined is placed on a TLC plate, which is made of a glass plate or a plastic sheet coated with a thin coating of absorbents such as silica gel, alumina, and cellulose.
Next is theory. First is stationary phase. Stationary phase is a layer of silica gel that fixed on to a glass plate. The stationary phase on the plate is of uniform thickness and is in a fine particle. While for mobile phase is a solvent which travels up the plate carrying the substance. The mobile phase that we use must be particulated free and of the highest purity for proper development of the TLC spot. As for polarity, if the silica gel is used as stationary phase, it is molar. If they are given two compounds in different polarity, the more polar compound has a stronger interaction with the silica. Therefore, polar compounds move slowly with the mobile phase and difficult to exit from the binding places and elute later. Consequently, the less polar compound move higher up the plate and elute first. This consequence resulting a higher RF value. Next, let's move on to principle of thin layer chromatography. First, compounds are separated based on the interaction among the compounds, the solvent and the stationary phase as dictated by their individual polarities. Second, the stronger the absorption of the compound, the shorter the distance it can move along the plate. And lastly, if the mobile phase is a polar solvent and stationary phase is a nonpolar, the more polar compound is more soluble in the mobile phase, so it will travel faster up to the plate. As for the less polar compound, it will strongly absorb to the stationary phase and will travel slower up to the plate. And last part for theory is advantages and application in thin layer chromatography. As for advantages, the separation in thin layer chromatography occurs more faster than paper chromatography. Thin layer chromatography have better separation than paper chromatography. Have a choice between different absorbent, spots are more discrete, can withstand corrosive detection reagent without harming the absorbent. As for application, It is to separate the compound in a mixture, to separate components of ink and dyes, to separate color pigment in plants, detection of pesticides or insecticides in food, and lastly, analyze the dyes composition of fiber in forensics. And that's all for theoretical in thin layer chromatography.
This is a procedure TLC of herbal extract. First of all, we need to clean and dry the plate. Second, place the glass slide on the top of surface tissue paper. Third, pour silica in the beaker. Fourth, pour distilled water slowly and stir with glass rod. Fifth, stir until the mixture having fluent consistency. Sixth, pour slightly gel silica into the plate. 7. Let it dry in the room temperature. 8. The silica gel should spread evenly on top the surface of the plate. The first step is preparation of the TLC plate. Draw a light pencil line near the bottom edge of the TLC plate. This is the origin line where you will spot the samples. Using a capillary tube, spot a small amount of the herbal extract onto the origin line. Allow it to dry and repeat if necessary to ensure enough material is present. Second, development of the plate. Pour the solvent system into the developing chamber to a depth of a few millimeters. Ensure the solvent is below the origin line. Place the TLC plate into the chamber, cover it, and let the solvent rise up the plate by capillary actions. This process separates the components of the extract. Third is visualization. Once the solvent front reach an appropriate height, usually 3/4 of the plate, remove the plate immediately and mark the solvent front. Fifth, allow the plate to dry. Visualize the spots under a UV lamp. If compounds do not fluoresce, use appropriate spray reagents to reveal them. 6. Analysis. Measure the distance each spot travel from the origin. Calculate the RF value for each spot using the formula and refer to the slide. This is the result TLC of herbal extracts. As you guys can see, there are at least 3 different substances found in the herbal extracts, which could be flavonoids, alkaloids, and terpenes. The precise identities of these compounds can be verified by additional analysis, such as comparison with reference, standards, or additional chromatography techniques. Indicates a non-polar compound that did not travel far up the plate, or a highly compound that interacts strongly with the stationary phase remaining near the origin.
To sum up, chromatography plays a pivotal role in the analysis and understanding of herbal extracts. This powerful analytical technique allows for separation, identification, and quantification of the individual components within complex herbal mixtures. By providing comprehensive information about the chemical composition and the quality of natural products, chromatography has become an indispensable tool in the field of herbal research and product development. As the demand for the safe and effective herbal products grows, the role of chromatography in ensuring quality, purity, and consistency will become increasingly important for the regulation and standardization of herbal industry.
Thank you for watching. Don't forget to like,
Comment
and forget to share. CHM256 is a